So way to test for symmetry. Suppose we have some function f of x. And we change x to negative x. And if the result is f of x, in other words, the original function, you get it back, then the function is even. Easy way to test it. We did a bunch of them last time. So as an example, let's say f of x is equal to x squared. Is that an odd power or an even power? Even. So the function has to be an even function. And as I mentioned this in this class, anytime you have an exponent, what do? Parentheses. Very good. Especially in a problem like this. So now you're going to replace x by negative x. What would happen to that negative? It'll turn to positive. In other words, it's going to go away because negative means -1 squared is +1. So we would simply have x squared. Isn't that the original function? So the function is even. We'll do the same thing again. You change x to negative x. And if we end up getting negative of the original function, so the negative moves out front, and if that happens, then the function is odd. What power do we have? Odd. We have to change x by negative x. So I'm going to have f of negative x. Negative means -1. What is -1 cubed? -1. So when you cube this, you will have negative, and then you have x cubed. But you have to realize, you may jump to conclusion and say, well, this is not the original function. Well, that is the point. You have negative here. If I write it that way, I realize that x cubed is the original function. Yes? So we simply have negative f of x. So we know that x cubed is an odd function. Now the test is sort of giving us the same answer. So this would mean the function is odd. Sometimes a function could be neither even nor odd. And it could happen, in which case we simply say the function is neither even nor odd. Are we clear? So I'm going to give you 3 different functions. Let's see if you can determine if they are odd, even, or neither. That's one. So 3 functions, I'll give you about 3 minutes or so. Let's see if we can get it. So the first one is x raised 4 plus x squared, or x squared plus x raised 4. Same thing. With practice, you can look at the function and recognize, oh, it's even. Oh, this function is even. If I replace x by negative x, I have negative x raised 4 plus negative x raised 2. So negative 1 raised 4 is positive 1. So x raised 4. Negative x raised 2 is positive x squared. And this is simply the original function. Yes. So this function is even.
Even though you switched up the power 4 and the power 2.
What is 2 plus 3?
Oh, no, I know. I'm just saying.
Oh,
That was just simply.
I recognized it, but it's the same thing. So whether I write it as x raised 4 plus
I was just simply saying.
okay. Yes. But you do see that.
Oh, yeah.
Doesn't matter, right? X cubed minus x, we have to replace by negative x. So we will have negative x cubed, negative of negative x. Negative 1 cubed is negative. You have negative x cubed. Negative times negative is positive x. Pay close attention. I've seen students stop here and say, well, this doesn't look anything like the original function or the negative of the original function. So they would simply say this is neither even nor odd. But what are we trying to determine? We are trying to determine if f of negative x is equal to f of x, or f of negative x is the negative of f of x. So always try and pull a negative out if you think that the function might be odd. If I pull a negative out of x cubed, I'll simply have x cubed. There is a positive here, and if I pull a negative out, what would happen to that positive? It becomes negative. This part is the original function. Yes? So f of negative x is negative f of x. So the function is odd. Last one. I was so tempted to write this as 1 plus x squared, but I didn't. So we have to write it. We have to change x by negative x. Negative x cubed plus negative x squared plus 1. Negative x cubed would mean I pull the negative out, x cubed. Negative and the square would go away. I'll have x squared plus 1. Just by looking at it, this doesn't look anything like that. So we know that the function is not even already. One more step, we want to test for symmetry also, so I'm going to pull a negative out. So negative x cubed, negative comes out as positive, we have a negative, negative comes out as positive, we'll have a negative. That's what we would have. Does that match the original function? It doesn't. So it's not equal to negative of the original function, so it's not odd. So this particular function is neither even nor odd. Does that make sense?